Hello, welcome to question 9. I've had a look at this one. I've seen standard deviation appear. If you're able to use your calculators to immediately get the standard deviation and estimates for the mean, fair play, well done. But I'm going to go through this the old-fashioned way. Grace Hockey, our sponsors. Haven't mentioned them for a few questions, but they are with us always. Okay, so we are estimating a mean for the times of these swims. First thing that I know that I need to do is I need to find midpoints because this is grouped data. So 14.25, are all of these groups the same? Yes, they are. So all I need to do is add 0.5 to these. 15.75, 16.25, 16.75. Next job, I'll call these T, is I need to do ft, which is the frequency times by the time. So that first one's easy, 28.5. 14.75 times by 5, 73.75. 15.25 times 7, 106.75. 15.75 times by 12, 189. 16.25 times by 16, 260. 16.75 times by 8, 134. Right, we need to add all of those up. I've got all of that. That's 50. The frequencies are quite easily done. So all of these are added together. 73.75 plus 106.75 plus 189 plus 260 plus 134. I'll double check I haven't done the old answer at the start. No, I have not. 792. So 792 is then divided by 50, and that is 15.84. Lovely. Part B, explain how you can check your answer is sensible. Answer is within the range of the given data. So if my answer was 158.4, I know I haven't divided properly, but 15.84 falls within this group here, so therefore I'm happy with that. Okay, so here it is, estimate the standard deviation. So what we need from here is ft squared. And that means that ft is multiplied by t. If you square your values of ft, that gives you f squared t squared. That's not the correct data for standard deviation. So we're going to have to multiply all of these by the midpoint again, which means some of these numbers could get quite big. So 28.5 times by 14.25 is 406.125. 73.75 times by 14.75, 1087.8125. I'm going to do all four of these, so feel free to skip ahead if you want to, or if you're helping me increase my watch hours, play it on loop. Play 6 or 7 tabs on loop. Help somebody make a difference, because the more watch hours I get, the more likely I will appear on searches, the higher up the lists I will be. And if I can help people pass their core maths exam, that's what it's all about. 4225, 16.75 times by 134, 2244.5. We're then going to have to add all of these up. 406.125 plus 1087.8125 plus 1627.9375 plus 2976.75 plus 4225 plus 2244.5, and I hope my handwriting has been readable there. Okay, so that is my sum of the ft squareds, and I'll come back for that piece of data. So standard deviation is going to be the sum of the ft squareds over, we'll say n, take away some of the ft over n. So that is the sum of the squareds take away the mean squared. Right, where's my value? I had it. I've got it on my calculator. We're okay. 12568.125. That's over 50. Take away. I could just use my mean, but I'm going to put the values in. 792 over 50 squared. And then that becomes a calculator job. So square root, fraction button, 12568.125 over 50, take away, open bracket fractions button, 792 over 50 squared. Oh, wonderful. 0.6759437846, which I will round to 0.676. Okay, so we're on to part D now. Swimming coach helps with Ralph's training for 6 weeks. Here is some information about his 800-meter training. Swims after his coaching. So I'm just going to put before here. 0.676. And what was his mean? 15.84. Oh, he's got better, hasn't he? But how? Compare his performance before and after. So his performance improved after the coaching because his mean time reduced, so he got faster, and his standard deviation reduced, which means he was more consistent. Okay. That's it. Question 9 is done. I will see you at question 10.